We are continuing on with Chapter 7 today. This is the Day 2 notes. It's the first day we're going to talk about mixtures. We're going to work on mixtures again tomorrow. You will have homework both days. And then we'll end up quizzing the week you come back from spring break. So you're going to have to keep this in your memories for a while. You have this little graphic up on the top of your notes. Everybody see it? We're going to set these problems up in a very special way. Okay? What you're talking about goes here. Label that on yours. That's what you're talking about.
Should we draw those lines?
Yes. So if you're talking about peanuts or copper or sulfate or solution, it's sort of like scientific-y today. So whatever you're talking about, whatever you're mixing, that goes in the bottom. In the middle, that's how much you have. And then up in the top, we're going to talk about the value of each. Sometimes we're talking about price. Sometimes we're talking about a percent of the solution. But that information goes up there. So I believe these are supposed to represent like paint cans. Like this is all about mixing stuff together. So you're mixing this, you're mixing this. You want to get this result. How much do you need? Is how the problems are going to look. So the cost or the percent or whatever is like the qualifying item, that goes here. How much you have goes here. And what are you even talking about goes here. In each of the little canisters, and then we're going to write equations. These are challenging. They're word problems. Word problems tend to be a source of trouble for a lot of you, so just try to follow the graphics. It seems like those that set up the problems right usually can solve it. It's the people that try to do it their own way that struggle. So just try to set it up with me today and just follow along. Here is example 1. How many kilograms of 45% copper alloy must be added to 62 kilograms of 60% copper alloy to form an alloy which is 50% copper? So they're making a mixture. It's like they have two cans of this mixture. One of them is stronger than the other. 60% is higher than 45%, right? So they have one that's 60% copper. They have one that's 45% copper. They want to pour them together to make 50% copper mixture. Okay? We know how much of the 60% alloy we have. We want to know how much of the other one, the lower percentage, the 45% alloy we would need in order to pour them together and make something that is 50% copper. Okay? So let's draw our little canisters. This is all math. It's just symbolizing a mixture. We're not actually mixing paint. Although there is a lot of math involved in that. Okay, so what goes where?
The 60% copper in the first can.
I'm going to go in the order they were given. So I'm going to call the first one alloy 1. The next one is alloy 2. And that's going to give me my mixture. So that's what I'm talking about. Sometimes it's peanuts and almonds and walnuts or whatever. Sometimes it's actually solutions. In this case, we're talking about different alloys, different metal combinations. Okay? Now, how much you have goes here. How much of the first one do I have?
45%.
That goes here.
Unknown.
Unknown. When I don't know something in math class,
X.
I use an X. So the 45% goes in the top. I don't know how much of it I have. and that represents alloy number 1. What are your questions so far? Okay, what's in the second can before I pour them together? 60%. And how much do I have? Yes.
62 kilos.
Good. Now, when I add these together, I want a mixture of what percent? 50%. Now, the amount that I have will be what? X plus 62. Good, because however much of this I have, poured into however much of this I have, that's how much the mixture will have. Perfect.
Do we have to call these every time?
Yes. Okay, what are your questions? No.
Oh.
All right, now we're going to write our equation. When you put percents in math equations, do you remember what you have to do? Turn it into a decimal. What's 45% as a decimal? 0.45. What's 60% as a decimal? 0.6. 50%. 0.5. Good. If you're unsure of that, start with the decimal in the back, jump it up 2 spots. Start it in the back, jump it up 2 spots, jump it up 2 spots, or just divide by 100 in the calculator. So I'm going to have 45% of this one. So 45% times x, 60 times this, 50 times this, but as decimals, okay? So my equation is going to look like this. 0.45 times x, 0.6 times 62, and then back here I have to use parentheses because the whole thing is my total, the total amount of this solution I have, and that needs to be 50%. Questions so far? Now we got to solve it. But I am out of room, so I'm going to go to the next slide. All right. So we need to do what? Yeah, multiply. So we can multiply the 0.6 and the 62, and then we can also distribute the 0.5. So 0.6 times 62 gives me 37.2. In the back, you distribute the 0.5. So 0.5 times x and 0.5 times 62. Now what? What?
We add the x's.
Yeah, we need to get our x's together. They're on different sides of the equal sign. So you want to go ahead and subtract.
Why don't we subtract the 0.5?
You could subtract the 0.5, but you'd end up with a negative x. We like to avoid negatives when it's possible. But if you subtract the 0.5x from both sides, you'll end up with the right answer. Now, careful here. I feel like this is one where I'd see a mistake. I feel like a lot of you would put 0.4x, but you're off by a decimal. So careful on this one. Yes, Josh?
Would that be 37.2 equals 0.05x plus 31?
Mm-hmm. Now what? Subtract the 31 from both sides. And then divide by 0.05. Anyone know what you get? $124, and we are talking about kilograms of the first mixture, remember?
But how did you get 124
When you divide by a decimal, you get a larger number.
However, if you did.
If you want to do it, write it out in long division. And then you have to move the decimals the same number of jumps. You get it? All right, any other questions? All right, here's example 2. It's all about Susan. Susan wants to have a mixture of walnuts and almonds. Walnuts cost $3.50 per pound. Almond costs $3 per pound. How many pounds of almonds must be added to 10 pounds of walnuts to make a mixture that sells for $3.40 per pound? So this is a good one, like if you're making something for a bake sale or something where you want it to be able to sell for a certain profit, right? So she wants to be able to make a mixture that she can sell for $3.40 per pound. Okay? Now, walnuts cost a little more than almonds, so it's not as easy as it sounds. She's got to figure out how much of each she wants. So we're going to use those same old paint cans. The first one is going to be about walnuts. The second one is going to be about almonds. And the last one is the mixture that she's going to sell at whatever this nut sale is. All right, so walnuts are $3.50. How many pounds of walnuts does she have right now? 10. All right, almonds are $3. How many pounds of walnuts are there? We don't know.
How do you know if she has 10 pounds of walnuts?
Because right here it says how much would be added to 10 pounds of walnuts. Okay. How much do we want the mixture to cost per pound? $3.40. And how much of that is there going to be? X plus 10. Or 10 plus x. Addition is commutative.
X minus negative 10.
Okay. Let's focus on just the basics here. All right, so we're going to do our equation next. Does anyone think they know what the equation will look like? Yes, sir. Not you, sir. You, sir. Go.
3.4x plus 3.5 times 10.
Wait, what are you doing? Yeah, let's just go in order.
Okay. 3.5 times 10
Okay.
plus 3 times x equals 3.4 times x plus 10.
Very good.
More.
So this is our equation. I heard someone try to move the decimals. That only applies when we're doing percents. When we're talking about money, the decimals are fine just where they are. Okay, so we got to solve this bad boy. What's 3.5 times 10? 35. And in the back, we're going to distribute the 3.4 to the x and to the 10. So we'll have 3.4x plus 34.
We subtract the x.
Yeah, let's get our x's together so we can subtract 3x from both sides. That gives me 0.4x. Now we can subtract 34. We end up with 1 equals 0.4x. Divide both sides by 0.4.
2.5.
This is where I would type it in the calculator. If not, you can jump your decimals back. And it ends up being, you need 1 jump on the top, so 10, 1 jump on the bottom, so 4. 10 over 4, which reduces to 2.5. I would use a calculator for this section. I'm not a big fan of decimal multiplication or especially decimal division. So I would rely on that technology if you have it. What are your questions? We got one more we're going to look at today.
Oh, yeah.
This takes a lot of work.
Yes, they do take a while. That's why we're spending 2 days and we're only doing 3 of them today. All right. How many liters of water must be added to 20 liters of 24% acid solution to make a solution that is 8% acid? So, you got to kind of think about this one because the water doesn't have a percent. How much acid do you think is in water?
2%. It's points. Water?
None. Yeah, I'm not drinking acid for lunch.
They're actually. You drink orange juice?
Unless you want to, like,
Dude, drink
burn
orange
your
juice.
breath up.
I mean, I'm just saying, the water I've been drinking is not an acid solution. Okay, so the first one's water. I don't know how much water there is. I'm assuming there's no acid in my water. The next one is the acid solution. I have 20 liters of it. It's a 24% solution. I want my final new solution to be 8%, and it's going to be however much water I have plus the 20 liters of the original acid solution. Okay? So I'm just going to fill in the gaps that we talked about. So that's a 0 and an X. This one's a 24% and a 20 for 20 liters. In the back, I want it to end up being an 8% solution, and I have X plus 20 for my amount. What?
So does water actually dilute acid though?
I believe so.
That's fine.
Yes.
Also, it depends on what water you're talking about. Some have acid.
Assume that if we're talking about water and I don't tell you anything about the acid level, assume it's 0. Okay. Okay. Yes. We're going to assume it's 0. So, shh. Quiet down. All right. Here is my equation. So 0% times however much I put in. 24%, well, 24% as a decimal is 0.24, so make sure you change it to a decimal before you put it in the equation. 0% is 0%. You don't need to move the decimal around. 0.08, I just did what I was going to warn you not to do. Sometimes students just want to put the decimal in the front. It doesn't work when it's only 1 digit long. So make sure you're doing 2 jumps, so you'll have to fill in a placeholder 0 there, okay? And then that's going to be multiplied by however much of that I have. So I'm going to add the amount of water, the amount of the solution. It's X plus 20. Keep it in parentheses. Questions so far? Now, this guy works out kind of nicely because 0 times X, you can just cross it out. 0.24 times 20. 4.8. In the back, we distribute the 0.08. We end up with 0.08x plus 1.6. Then what? Subtract 1.6 from both sides. We end up with 3.2 equals 0.08. Then what? Divide.
40.
You got 40.
40. Good. 40 liters is our answer. Tons.
Like how many tons?
Tons of tons. All right, what did we learn about today? These are all about mixtures. All right, I'm going to pass out your homework. We will continue talking about mixtures tomorrow.